Waiting to see. Ooh. Okay. Hello, Internet. My name's Waffle. I'm here at Discovery Place. We have my friend Pancake the Dragon behind me. And today we're going to be using Tinkercad, a free program on the internet, to design a slide puzzle. So before I start working, we've talked a lot about 3D printers and how you can make some pretty cool things. So some things I printed before is this is a little model of a DNA strand. You can see that it's pretty intricate, but it all prints as one solid piece, right? Same thing goes for, say, this little dragon, which you can barely see because of the exposure, but if you look at his nose, you can kind of sort of see those layer lines. And so anytime you see these layer lines, that's a hallmark of 3D printing. But these are all solid. You can also make stuff that moves, right? And so 3D printers, because they're laying down multiple layers of plastic, you can slowly shift and change the way they look to make other things. So this is a fun little toy. It's a little Flexi Dragon. It's a little hard to make, a little complicated. So today what we're going to be doing is we're going to be making a slide puzzle. So I have a tiny little slide puzzle right here. Some of you and your parents probably remember these, right? You can kind of move them around and try to solve it in a certain different order. And we actually have a bunch of different types, right? So this is the bigger one. So you see this one, the letters actually come out as opposed to coming in. And then here is my first attempt at making a slide puzzle. You can see it says design by Waffle because I have an ego. And so right here we can see this moves around, right? But I want to make this a little bit better. And so today that's what we're going to be doing. So if you look here, the program we're going to be using is going to be Tinkercad. I've talked about this a lot. It's a free program online. You can make an account and you can design all sorts of things. Here at Discovery Place, we actually use this website to design things and print things here. And so I know you can't come to the museum right now, but while you're watching this Facebook Live, you are welcome to open up Tinkercad, make an account, and start designing things, right? It's a lot of fun to watch other people make things and do art, but we're really about having you learn how to design and do modeling, right? I'm 27 years old. I've been modeling for 2 or 3 years, right? If you're a kid and you start now, by the time you get to university age, you'll have more years of experience than I would, and you could actually start making better things than I can, okay? And so, can go here. So when we're designing this thing, a big principle in the Thinkerspace is iterative design, and that we're actually gonna try to make something, see how it works, go back and try it again. And so that's actually why I showed you this first prototype, because I tried doing this at home first, and now I'm going to try making another one. All right, and so to start off, what we're actually going to do is we're just going to go to Paint. Lovely old Paint, you know how this works. And the key thing when I'm thinking about my design is that I'm going to make a little box, and then I'm going to say, cool, I want the inside to be like this. And then I'm going to actually just put little squares wherever I want my puzzle pieces. Okay? And my design doesn't have to be perfect, right? We just want to take whatever we have in our head and put it on paper. Because sometimes when we put and draw the things down, it really helps us get an idea of what we want to have made. Because sometimes it all makes sense in your head, and then you put it down and you realize, like, oh, that isn't going to work. Okay? So this is basically, and here I can actually click a fill button. Where is it? I can click a fill button to say this is where my solid pieces are going to be, and this is going to be my gaps. Now, the critical thing for making a slidey bit is that if we were looking at the side of my puzzle piece, okay, I'm actually going to want to make a little channel. So this puzzle piece is actually going to come out like that. Copy that, right? And so when I fill this, the puzzle piece is going to look like that. And then there's going to be a little groove on the other side that catches that puzzle piece and then moves on like this. So this is how my puzzle piece is actually going to be able to slide. Because if we come back to the webcam view so you can look at me, so this big puzzle might be the best one to do it with. Do you see? Whoop, whoop, whoop. We see that little groove in that channel? And if I look in there, I can actually see that this piece is able to slide. This is so hard. It's able to slide in there like that. And so you actually have to have 2 sets of grooves so things can move all over the place, okay? Well, now that we've had the basic plan laid out, we can start designing stuff, right? So let's shrink this down. Let's go to Tinkercad, right? So I'm here in Thinkerspace, and I'm just going to go create a new design. Right. Hopefully this loads. So let's see, little Tinkercad. It'll automatically generate a random name up here, and so you can actually click that and change that. So I'm going to say this is Facebook Live Slide Puzzle. All right, ta-da. This is our little work plane where we can modify everything. So what I'm going to do here, and let's see, okay, webcam isn't blocking anything, that's good. I'm going to start off by just taking a box. Ta-da. I got a little box down there, nothing exciting. Let's shrink it a little bit. All right, cool. So this is my one piece, and now I want to make those little slides I talked about, those rails. So there's this roof piece down here. I click that, remove that, and ta-da. Now, using these rotating arrows, I can actually turn it. So what I'm actually going to do is I'm just going to use the default size for everything, so it's easier. Okay, I'm going to move this here. Now, the one thing, if you're trying to practice at home, you can click and drag things around in this XY plane. If you want to lift things up, you have to click this arrow, right? And once that arrow goes up, I'm going to look. I'm going to say, hey, that looks pretty good. I'm actually going to use my arrow key to bump it out just a little bit. So you can be very precise if you want. Now, you have that all lined up. That's cool. Well, I'm just going to copy this with Control-C, Control-V to paste it. I'm going to do it again. One thing, if I use the outside indicator, you'll see that I can actually change it by 1 degree increments. If I'm on the inside, it snaps for 22.5. And so this is easy if you want like right angles or 45 degrees. It'll definitely make things flow better for you. Boop. All right, so we get this lined up. So that looks pretty good. But the one thing you'll notice is that I probably want this inside portion filled in. And how am I going to do that? Well, what I'm actually going to do is I'm going to extend this that way. I'm going to click this, and now I can grab the bottom one. If you grab the white one, it actually lets you adjust all directions at once, so that can be confusing. If you click only the black square, it'll let you adjust only that one dimension. Now, what I'm about to do is a cool trick that utilizes holes to fix things. So if you notice, every time I click a shape, there's this solid and there's this hole button. A hole will turn it so that it actually removes stuff. So what I'm going to do is I'm going to copy this, I'm going to paste it, and I'm going to move it out here. I'm going to take this box, set this right here, line this up. Now what I'm going to do is I'm going to make this a hole, and it's going to cut out a shape. When I click this little join and combine button, it combines it, and now I have this shape that has the part of the triangle that's missing. And the reason I do this is because if I make this a hole, I can go and I can line it up right there, right? And I can say, okay, I want this to be applied to this buddy. Well, actually, I'm going to need to copy this because I'm going to have to do this operation twice. I'm going to have to click this here, whoop, click, click, combine. Boom, there we go. Now we look at this bit again, right? I'm going to copy paste. I'm going to put this over here. So one of the useful things to do while you're designing stuff is to take the things you might use and create a copy of it and just go put it somewhere else. So that way it's there if I need to use it again and I don't have to keep remaking this stuff. All right, so now I got this lined up. And now we can see. Looking in here. Oh, that's a little aggressive. Like that, cool. And that right there. Shift click, so I've now selected the two things, and I'm going to click group. And ta-da, that looks pretty good. But, okay, so now I'm going to take this, copy paste this. So far I've completed part of my little slidey thing, right? So we have the little edge that wants to slide into the other bit, like we talked about in the paint, right? You have this portion right here. Now, if we end up having each of these little pieces here actually needs to have two of those. So right? If I were to, this slide puzzle actually looks like this, right? The slide puzzle goes out and then it goes in. And right now my slide puzzle has the out bit and it doesn't have the in bit. So I copied this right here. I'm going to duplicate that. And this is actually why you see I kept this old piece. So if I can look at this, I can say, cool. I want to move that over there. I can actually get rid of this block. Well, so this is now the same shape, right, as that outside bit. So now I can line this up and I can say, hey, I want you to go right there. You want to check it so it lines up. And now we go 1, 2, right? Because this, I think, is actually the same that I had over there, right? Because if we go over here, we can check. We can say, all right, how far is this one? 1, 2. Okay, so we just want to make sure everything lines up. 1, 2. Okay, we're going here. All right, we won't check, and we're like, uh-oh, that doesn't go all the way. So we just do a little bit of an extension. Cool. And then we can combine these, right? Although I probably, before I do that, want to copy it because I'll use it on the other side, right? So 45-degree angle. We line it up nice and even, and then we do the counting. 1, 2. Okay, and then if I apply all this and I click group, ta-da, we have a piece that goes outside there, inside here, inside there. So this piece, right, once you have one of these, I actually can just copy and make a bunch of these. And so now is a good stopping point to actually show something about that's interesting about the way this stuff works. So the order in which you decide to group things matter. So if I were to take a square, a cylinder, and a cut tool, and I were to combine them, if I combine the square and cylinder first and then cut it, it looks this little square cut out. But if I were to cut the square with the square first and then add the cylinder kind of overrides and comes over top. So when we're actually designing and doing things in order, you want to be careful that the things make sense. And it's actually highly likely I'm going to make a mistake doing this at some point, and then I'll have to go back and fix it, and I'll catch it later. Okay? Then, so we're here. We've made one of these slide puzzle pieces, which is very cool. And so now what I'm going to do is I'm going to copy this and I'm going to paste it. I'm going to move it. And now you might be tempted to just kind of line up the puzzle pieces like this, right? And say, ta-da, I've made a puzzle. It looks pretty good. But if you zoom in really close, right, you can say, well, hey, maybe there's a teeny tiny gap here, right? But like, is that really a gap? How big of a gap should you make it? So there's actually this concept called tolerances in engineering. And what this is this is like the allowable amount of variation of space, right, in dimensions. So think of it as if my hand is a hole, right, and I'm trying to put something in it. If it's too big, it won't fit, right? And if our parts are too big, when the printer tries to print them, instead of the different pieces sliding around, it's just going to be stuck, and it's not going to move. So we're going to want to make sure that we have tolerances that our printer can handle, and most printers having a 1 millimeter tolerance is actually good enough for the printer, and it can handle that without any problem. And so you can see one of the things you might end up using here is this little snap grid down here. You can change how much it pops and moves with each movement, but it's already set on 1 millimeter for us, so we're good. So I'm going to move this over, boop, 1. I'm going to move this over, boop, 1. Right? So now we see that's pretty good, right? So we can actually look down that, and then if I line it up properly, you can actually see daylight, right? You can see through the things, so we know that they're not touching. Well, now I'm just going to take this, select all of them, copy, paste. It's so much easier to have a computer do the duplication work for you than you have to do it. All right, I'm going to go down and copy, paste again. And see, sometimes if you just want to be accurate, you can just use your arrow keys the entirety of the time. Ta-da! Delete. And so you can't have 9 pieces in the slide puzzle. You have to have 8, because if there were 9 pieces, you wouldn't have anywhere for the puzzle to slide. So this is pretty cool. Now what we're going to try to do is we're going to start designing the outside border. Okay, so once again, we have my fancy dancy piece I saved over here that's going to become oh so useful. And I'm really just capturing that to reclaim this thing. Now, when I'm talking about this side, whoops, did I stretch that? Nope, okay. No. Woo! Okay. So, what we're going to do is we're going to want to create a frame around it. So, I'm going to drag a box here. And I'm going to say, hey, I want my box to be pretty close, like that, right? Same amount, but I'm going to have to cut into it. So we're going to take this thing, and we're going to line it up. 1, 2. Right? Yeah, 1, 2. Click both of these, and now we're going to stretch it. Gotta keep going, gotta keep going, gotta keep going. Okay, nope, a little bit more. And now for this one, I don't actually want it to be blocky on the side. I think what would be really cool is if I took one of these this round roof, as it's called, and I actually stuck it on the side, right? Because then it ends up looking like it's a little bit smoother as opposed to just being a block. So I can take this and reduce it in a little bit. There you go, looks pretty good. So I'm going to take this. I'm going to copy paste this and put it somewhere else for another time. But we take this, we group it together, ta-da! And then hopefully if I look down here in the center again, I can see that it's not touching anything. And yes, there's a little gap there. Cool. Next thing I'm going to do, take this, copy paste, 90 degrees. And if anyone is designing their own things and you have questions, comments, or concerns, you're welcome to post them and see if you need help, or I can explain more what I'm doing. I know sometimes people that do things a lot just kind of flow through things because it just makes sense. But if you're just here learning for the first time and you want to know why I did something or why something works, I'm happy to stop and tell it to you. Because however much I like being the center of attention, it's really about you guys designing and building your own stuff. So we're going to move that in a little bit to line it up. And move this in a little bit to line it up. Okay, cool, cool. And now what I'm actually going to do is I'm going to click these two things. Whoops, nope. These two things. And I'm going to look at what that edge corner looks like. Okay, and that looks pretty good. It looks inset, and here I can actually bring it up closer to me. Nope, I cannot. There we go. So here we see that that corner is nice and neat. There was a chance that I messed it up and I'd have to fix it, but I'm glad I did not have to do that. And then I just Control-Z to put everything back where it was. For this next bit, right, once again, I'm taking my fancy-dancy triangle, except now it's doing double duty and it is no longer a hole. So what I'm, so knowing the dimensions, so if I were to go here and I were to click, say this or here, let's just start with this cube because that will make things easier. So if I have this cube here, so one is this edit grid shows your units. You're in millimeters versus inches, right? And you can say how big this kind of base worksheet is. But if you see, whenever I touch these things, how little numbers pop up. So if I click here, I know that my cube is 20 by 27 by 20. And so if I stay here and I start dragging it, if you actually look at those numbers are changing as I'm moving it. And so you can say, hey, I want this to be 10 by 30, and it'll happen, right? So you can also input dimensions like that if you don't want to move it like this. Okay?
Someone asked what the round roof was for.
So this round roof, so here, I'll switch to the webcam only view for a second. The round roof is basically to make this puzzle kind of smooth around the edge of it, right? So if I were to do just the block, it would be very blocky and it would just kind of have the sharp edge to it. That wouldn't be very fun. So what my goal is when I use this round roof, right, as I deform it, is to take the round roof and to kind of put it on the side, right? So if we're looking here, we can actually see that if this became a solid piece, this would be a little bit smoother and would just feel nicer organically than to have an edge, right? This, my first puzzle I actually made, has a solid edge, and as a result, the corners are actually sharp enough to cut somebody, which I do not want to give someone a present like, hey, here you go, watch out, it'll cut you. So like to be careful, and granted, I only know to put that on there because this is the second or third time I've made this puzzle, right? It's you learn and you practice and you do that iterative design. So you make one and you see how it goes, and then you make another and make any changes, right? And that's actually one of the wonderful things, right? It's why our products oftentimes keep getting better and better. It's because we learn lessons every time. But so now that we've done those inside bits, right, you know that these two corners, the pieces kind of push out, and so on these corners, they're put in. So instead of having to cut something out, I actually get to just kind of place this close. All right, so we see here right now that that is perfectly lined up, which we don't want it to be, right, because it'll be connecting. And if we look here, each of these pieces, we remember is one step away, so I'm going to do the same thing here. One step. And now this has that kind of gap in it, right? And now I don't get to see the daylight on the other side because there's that piece, but I can see that the gap is supposed to be there. Okay, so what I'm going to do is I'm going to copy pasta. Just copy paste, said in a weird way, for anyone who's wondering what that was. We are now going to see if we can do it again. So we're going to line up here. I'm going to say, hey. And so what I actually might do is I shift this one out of the way so I can actually look here. So that one looks like it's perfectly lined up. And now it's off one click. Yes, 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 that looks good. Yep. All right, I'm a happy camper. So we're going to move this down. We're going to move this back. And now let's shorten this inside so it's inside that little border piece. So we don't have any pieces sticking out. We got the same thing there. One thing I'm going to do is I'm going to make sure that this piece extends a little bit more so we don't have any internal voids or holes. Okay. And now what I want to do is I actually want this thing to be the same, this edge to be the same width as this edge. So I'm actually going to copy this, separate it out. I'm going to delete that piece, delete this piece, and now I kind of have this that's the same size. So I'm going to move one of these over here. I'm going to copy another one. Move it over here. And let's see, that all works. So that's a little bit of a space, so I can probably, there we go, we got the one gap again, right? And so making things look consistent is nice. I mean, and it doesn't always happen on your first try, right? In my personal opinion, right, perfection is the enemy of progress or something. You don't have to get it perfectly right. If things are just mostly there, then that's good enough because it'll make you content and happy in the end, right? So here we see that this looks pretty good so far, right? All connected. And so now it's time for me to put on these roofs, right? So we're putting this on the side. Wait. Nope, go back. There we go. And now, just like we had to modify the inside pieces so that it had a nice interlocking piece, we're going to have to do the same. So I'm going to copy this thing, and I'm actually going to copy it for nope. So sometimes you have to be careful where you drag. Okay. There we go. I'm going to paste again. Paste again. Nope. And one more time. So now hopefully you can kind of sort of see that this is a little bit smoother and looks nicer in terms of the edges. So one of the things I like to do is then go in and double check everything. Okay, so I'm going to extend this past in the edge there, extend this past, and the reason we're doing this is because we're actually going to go back and we're going to use a fancy tool to kind of cut this off. And so what this will do is right there at that seam, it actually will look nice as opposed to being a little uneven and rough.
Someone asked how much 3D printers are.
So it depends, right? If you want a medical grade 3D printer to print somebody's ear bones, that might be $10, $20, $100,000. The Ender 3 is a 3D printer that's about $200 or $250 that you can actually kind of get at home. And when we 3D print, that uses filament. So this little roll of plastic. And this roll of plastic is a kilogram, that's 2.2 pounds, and that is only about $20 or $30 on Amazon. So it's not necessarily the cheapest thing in the world, but for something that you can design and print and build yourself, I think there have been people that have done calculations and say that if you buy a 3D printer and you print yourself one thing every 2 weeks, you pay for the printer. Right? And setting aside the fact that you can print like really cool toys, right? Like this slide puzzle in terms of plastic cost probably costs about 40 or 50 cents, right? So you get the value from designing the things and from playing with them. And there's websites that have thousands of models available. So sometimes you just go to Thingiverse and you just download all these models and you can make your own stuff. It's pretty cool. At least I like it. There we go. So what we're going to do is we're going to have this pop out just a little bit more. But yeah, and I really like that this program, like this Tinkercad is a very basic modeling program, and it's really aimed at children. And that notion that we have these blocks, we have these shapes, and we can edit and manipulate it. Just because it's made for kids doesn't mean it isn't powerful. You can make lots of really cool stuff with it. It just takes away some of the more difficult and convoluted stuff. But if you start modeling in Tinkercad and after a couple weeks or months or something, you want more powerful tools, there are 3D modeling software like Blender or other ones that you can use to make more complicated things. So something like this dragon or this DNA strand was modeled in a different program, and there's still lots of free ones that you can use online. And oftentimes in the future, so there's this idea of designing things and having an object and having manufacturing. But then there's intellectual property. Well, so in the future, if 3D printers become widespread, instead of going to the Home Depot to buy a wrench, you'll go online and these stores will say, oh, these are our models for a wrench. And you say, well, I want that wrench, and it'll be printed at your local pharmacy or quick stop store. So you could just stop by and pick up whatever they needed out of a 3D printer. If you wanted some cool thing, you could just print it, and you're paying for the model. Because in the end, yeah, having the printers are cool and you can make lots of fun stuff, but it's really the people that make the models and actually are designing the thing that make 3D printing possible. If you don't have any 3D models, you don't have any 3D printing. Okay, so now I've kind of set all those round roofs around so it kind of looks nice. So now it's time to make that same type of cut tool, right? So if you remember when I made this cut tool over here, I had a little cut block coming out of it. I'm about to do just the exact same thing, but with this dome piece. So I'm going to take that. Let's actually extend this a little bit. Okay, that cut tool looks about the right size. Here, let's actually move that one over. Haha. Okay, good. I was a little worried it was overlapping just a little bit. So let's click that and let's combine them. Boom! See that? We got one A-grade cut tool. So we're going to turn this into a hole. So what I'm going to do is I'm going to line that up right there. I copy paste because I'm going to need another one. Now remembering I'm using this cut tool to cut these two, right? So if we look, these are the ones that extend. So I'm going to control click that, or sorry, click this one, shift click that one, and shift click that one, and now we're going to combine. So you see it's only cut off the ones there. Now copy paste, rotate 45 degrees, or 90 degrees, whoops, math is hard. Put that there, and then we say, okay, cool, I'm going to click this one, shift click this one, shift click this one, combine. And now we can really see that this corner looks nice and smooth. And so it kind of curves, doesn't have any sharp points, right? And is general more kid-friendly. Copy paste. Move that one up there. And the one thing you guys should that will definitely help you a lot when you're designing something. If you notice, I'm constantly moving around, looking at it from different angles and different perspectives. One of the mistakes people will make is you'll do something like, hey, I want to place a box. And so there's my box. And oh, I want to put a roof on my box. And so I put my roof on my box, and I lift my roof up onto my box, and it's on my box, and I moved it, and it's on my box, right? And I'm a happy camper. Whoops, I'm like, oh no, I gotta fix it. I'm like, yay, I made a house. It's so pretty, it's so special. I'm like, wait a second. You realize that you actually, because of your perspective, put it in the wrong spot. And so I'm constantly looking from all directions, because it isn't just a 2D picture, it's a 3D image, and you gotta look at it from all directions. Right? This is why if you actually look in a lot of engineering diagrams, they'll have a view of the object from the front, and a view of it from the side, and a view of it from the top. Because all of those different directions have information, right? Because looking at this puzzle, we know it's a puzzle looking at it from this direction. If we were looking at it from the side, what is that? What does it do? What's inside of it? Well, there's no way for you to really know without having that extra information. So here we go. Got that there. So once again, Control, Shift click, combine. Whoops, I pressed the wrong button. So this button here is the combine button, group. This is the ungroup button. So fortunately, Control Z is undo, and helps a lot. Click this one, this combined into one. Click combine, see what happens. Okay, there we go, pretty cool. All right. Next, and we got our last one. Flipping it around, lining it up. Looks pretty good. I'm going to shift click here, and I'm going to group. Ta-da! So this looks pretty good. Okay, so now what I'm going to do, probably get rid of that, get rid of that. So this is the base for my puzzle. Now I want to give it some numbers. Well, so in Tinkercad we have a whole lot of basic shapes and stuff, but you can also go down here to say text and numbers. Ta-da! So here, let's go to the number section. 1, 2, 3, 4, 5, 6, 7, and 8. Now, the reason I put it over there as opposed to on top here is that A, one, just placing it off the thing to get all the parts is faster. B, this is the fun bit. So I'm going to get all this stuff, right? Now that I've selected it all at once, any action I do to it changes everything. And the reason I want to do that is this isn't where the numbers go, right? The numbers need to be higher. So I can lift all the numbers at once, and all the numbers are going to the same height. I kind of go down here, and I can look. And now, sometimes when we're designing things, we end up getting to make decisions. And this is one of those times. Do I want my numbers to come out of the puzzle, or do I want them to come into the puzzle? Right? This is something that should end up being fine either way. But I'm going to put my numbers into the puzzle, and that is for one reason. So here, I'm going to switch back to my webcam only view for a second. Right? What's the difference? So this, the numbers come out. This one, the numbers are in. But you might actually see that right here, this one popped off, right? Just entirely. It's gone. And so because it's only this tiny little bit of plastic, this could actually get caught. It can get damaged. And remember when I talked about how the edge of my puzzle might be really sharp and like unfun? Well, if that puzzle was sharp, these numbers on here, ow, like this sandpaper. I don't like that. So I'm going to sink my numbers in like this puzzle so that it ends up just being better, right? So that was one of the mistakes I made the first time I was trying. So now that we have our numbers here, I'm going to look and I'm going to say, okay, let's have them so they're not touching it. Now you can see them sink in a little bit, right? So we're going to sink them in. Whoop, I'm only going to sink them in one unit though. And now I'm going to turn them into holes. Whoop. Okay, now we get to adjust and line everything up. So I put one down. I put one there. I put that there. I put that there. Boop, boop. And then, let's see. Okay, let's look at that. Everything kind of look even. Everything looks even. Maybe my 4 isn't even. Right, but once again, right, even if one of the letters is slightly off, it is not going to be the end of the world. We're going to be fine, right? Okay, this seems to have worked. So what I'm going to do, I'm going to export as an STL. And I'm actually going to have to slice this in a computer to see how it works. And then sometimes that's a second check to see if I made a mistake, as I'm still waiting for this thing to download. STL. It said downloading model. Maybe it downloaded automatically. Let's find out. Oh, there it goes. It just happens so fast. Usually it pops up in this little bar. I guess not today. Okay, so what we're going to do is I'm now opening Cura. So this is a different slicer. I think before I've used Pressa slicer, but Cura is free, just like Pressa, and this is for the jelly box. So this is a different type of printer we have. So I'm actually going to click Open, go Downloads, Facebook Slide Puzzle. Whoa, that's big. All right. So I'm going to take this, maybe scale it down a little bit. So we can see all the numbers, right? We see everything popping up, right? My next question is I'm actually going to go to Preview to see how everything works, right? So if we see there, we see that it looks like I have numbers there, right? I definitely have numbers. In my preview, I'm not seeing any numbers. So I don't know if that's an artifact. So here, let's try this. Let's make it big again and see what happens. Big. There we go. So we can kind of see that those numbers have shown up. Wow, that will take a long time. Okay, now, so you can kind of see that everything has kind of sliced and everything's ready to go. Now, instead of having everybody sit here for 4 hours, that'd be a while, I have actually gone ahead and taken one of the same puzzles that I've designed and stuff and done a time lapse of that, so I can kind of speed through that for you. So, let me full screen this. Alrighty, so this is a Pressa. This is one of our other printers. This is a fancier printer. It's about $750 if it comes as a kit. It's $1,000 assembled, but it is a very nice machine. So what it's doing is it looks and kind of detects where the base is, and then you see it actually puts down a layer of plastic and then just jiggles and moves around one thing at a time. You can actually look, you see here that there's a little motor here, that this motor controls the printer head moving back and forth. This filament coming down is actually the plastic, so if you want a different color, you change your color plastic. Most 3D printing is only in one color. You can get multicolor stuff, it's just more expensive. Right? And then if you are particularly eagle-eyed while you look at this thing, you might notice that you see some kind of lines right here on the side, and maybe you see some lines here, maybe you see some lines up here. So the cool thing about this pressa is that a lot of its parts are actually 3D printed. So this idea of 3D printers, there's this rep-wrap movement for self-replicating machines. And you say, how do I make a machine that can print another one of itself? And so obviously for this, you have to have some non-3D printed components, like these screws that move it up and down can't be printed, the motors can't be printed, there's a power supply and electronics, but in general they try to 3D print this as much as possible, just so that one pressa can actually print all the parts for another pressa in about 2 days. And so in the future you can think about, well, right, how can we do that?
So someone said that we should have done them different colors. Can you do them different colors when they print?
So when you do it,
the number's a different color?
yes. So this will print only in one color because there's only one color of filament going in, right? You can have different color changing systems. They tend to be very expensive, right? Because either one solution is you have two nozzles, so you get one color out of each nozzle, but now what if one nozzle bumps into the other one or something else bad happens? Or you could have two colors going through the same nozzle, but now you have to purge it. And so you can get multicolor printers. Having something print multiple colors in general is just baseline going to be an extra $300, extra $500, because you have to have a whole complicated system once multiple colors start getting introduced. And so we can see that the time lapse is ended, and what we're actually doing is we'll go back to the time lapse. And so this is what actually we printed. So we can see it's a nice little slide puzzle. You can move it around. And so let's see. Oh man, I'm not going to be able to solve this one upside down. Maybe I can. Maybe I'm a champion. I believe in myself. So what's that? We got 1, 2, 3, 4, 5, 6, 7, 8. Oh, look at that. I should have believed in myself. So yeah, this is our slide puzzle. That was Tinkercad, right? It's a wonderful free tool for you to use, no cost. It's the same type of thing we use. So when Discovery Place opens back up again and you want to come to the Thinkerspace, we'll have laptops set up and people can design their own things, and then we will print things for you in about under 20 minutes. And so we have 3 to 4 printers in the space, and so people show up, print their things, and then go off. Sometimes people will come, design an object, see it start printing, and then go enjoy the rest of the museum, and then come pick it up at the rest of the time. All right. Do we have any final questions?
I think we're good.
No? All right. Well, thank you, everybody. But actually, you know what? Let's show you something. You know, I talked about Dragon. Pancake is his name. Let's not do that. That would be tragic. So, we talk about designing things, right? Out of moving parts click together. This is Pancake. So you can see, here he goes. He actually weighs about 3 kilograms. That's like 6.7 pounds or something. See, he has big wings. I had a friend that also worked at Discovery Place sew the wings. And this dragon took about 17 days to print in between all the failures and other issues. And they all kind of clicked together. So this was made with a little bit more advanced modeling program. But once you learn how to make things that have moving pieces and interlock, you might be able to make something like Pancake yourself. There we go. Well, now I'm actually done. Thank you, everybody. My name's Waffle.